Today what we're going to look at is something called the distance formula. So the distance formula tells you the length of a segment that is graphed on the coordinate plane. Okay, so we're looking at the length of the segment graphed on the coordinate plane. So this right here is the distance formula. So the distance formula is the square root of, this is the quantity of x sub 2 minus x sub 1, that quantity squared, plus the quantity of y sub 2 minus y sub 1 squared. All right, so first, I want to talk about where that comes from, and you do need to memorize that formula. Okay, so let's first talk about where it comes from. So I have a figure here. I've named this lower point here x sub 1, y sub 1. That's the coordinates. The coordinates of this point up here are x sub 2, y sub 2. Now, the distance formula is based on Pythagorean theorem. And we know Pythagorean theorem works with right triangles. So what I'm going to do is I'm going to take this segment and I'm going to make a right triangle out of it. All right, so here's my right triangle. Okay, now we know the Pythagorean theorem. Okay, that is c squared equals a squared plus b squared. Okay, and now a and b are the legs. So let's think about the horizontal leg here. The coordinates for those come from taking the larger x and subtracting the smaller x. So really it comes from x sub 2 minus x sub 1, right? If you use your numbers that are here, this coordinate here at my right angle is at 5, and I would take 5 minus 2, which is right here, to get 3. That would be the length of that segment. Okay, now I can do the same thing for my vertical distance here. It's going to be the difference of my y's, the largest y minus the smallest y. So this is y sub 2 minus y sub 1. And we're going to call distance d just to make things a little easier here. I want to find the length. So using my right triangle, I know that my hypotenuse squared is equal to, now I need to square each of my legs. So my horizontal leg is x sub 2 minus x sub 1, that quantity squared. My other leg is y sub 2 minus y sub 1 squared. Now if I want the actual length of that hypotenuse, I need to take the square root of both sides. And this is where our formula comes from. All right, so that's where the distance formula comes from. You have to know this formula. We are going to use it quite a bit. Okay, so we're subtracting the x's and squaring them, and then adding that to the difference of the y's squared, and then taking the square root of the whole thing. All right, so we're going to practice this. It says, what's the distance between 1, negative 7, and 5, negative 4 when round our answer to the nearest tenth? All right, so this is my x sub 1, my y sub 1, x sub 2, y sub 2. So my formula, I'm going to go ahead and write it out. And I recommend, honestly, you writing it out a couple of times, because once you write it out a couple of times, you've got it. All right, so first thing, I need to find the difference of my x's. So I'm going to write this out more than I normally would. It'd be 5 minus 1, that quantity squared. Plus, if I do my y's, it's going to be negative 4 minus a negative 7, which is really positive. Okay, so if we can simplify within my parentheses, I end up with the quantity of 4 squared plus the quantity of 3 squared, which is 16 plus 9. So now I really need the square root of 25, which we know is 5. So the length of that segment is 5 units long. Now that one was nice and neat. They're not always that nice and neat.